Hello, my name is Maria from mathmammoth.com. In this lesson, we're going to look at cross-sections when slicing three-dimensional shapes. And it is a little bit difficult to illustrate, so I'm going to use a computer program here that shows us various solids, various three-dimensional shapes, and how the cross-section looks like when it is cut with a plane. This is called Cross-Section Flyer, made by shoulder.org. So here we see a pentagonal pyramid. It is called that because it has a pentagon here at the base. And now we imagine that there's a plane, as if a sheet of paper or something has cut this pyramid. And then what would we see if the top portion was cut off? We would see actually a pentagon here. And this program also shows it here as a two-dimensional shape. This is the cross section, the same as here. Let's look at this pyramid. I can use these controls. I can rotate this slice. And you can see how it changes. This is the same as tilting our cutting plane or the cutting paper. If you imagine it as a cutting paper or cutting blade of something, if you tilt it, how does the cross section change? It is still staying as a pentagon here, but elongates. And we can rotate this slice the other way. And move it up and down. Here there's a point where I move it down that it becomes a quadrilateral or four-sided shape. But now it is back to a five-sided shape or pentagon. I can also make this pyramid to have less sides here at the base. Now it is a square pyramid. And over here is a point where the cross-section becomes a triangle. And I just want to use this program because this is a topic that is pretty difficult to illustrate in any other way. I mean, if we had physical objects such as made of clay and then we could perfectly cut them, that would be the perfect situation. But I've tried that and it doesn't work super well. I think this is a better way. Now let's try another pyramid. Here's a heptagonal pyramid. The cross-section changes. It's a heptagon here, but I can make it to be something else. 1, 2, 3, 4, 5. Now the cross-section is actually a pentagon. All right, let's try a cylinder. Here we see an oval-shaped cross-section. If I move it up, it starts looking kind of interesting. Move it down, it gets cut off like that. It is like a part of an oval and then a straight line here. And you see these differences, how it's rotated. And I can make it a perfect circle too, like this. Then a cone. This is a circular cone, so here the cross-section is a circle when we use a plane that is parallel to the base. But if I tilt it, then it's an ellipse mathematically. And here it gets cut off with this straight line. And then we have a double cone. It's kind of a similar situation to a cone. Except here, where it is cutting both portions, both the upper and lower cone. So then the cross-section is in two parts. like that. This graph here actually is called a hyperbole. Here's a point where we get two triangles. But we can also just get the circle, like with the cone. And then prism. What kind of prism is this? Look at the base. What kind of a shape do we have at the base? A pentagon. So it's a pentagonal prism. And right now the cross section is a pentagon. And stays like that if I move the slice up and down. But start rotating. Here we get a hexagon as a cross section. The basic idea is just to understand that there's many different possibilities and to understand the basic situation. If you cut this shape with a plane that is parallel to the base, then you get the same shape as the base. Let's also try this prism. Now it is a cube actually, or rectangular prism if its height is more than width and length. So here is a rectangle. Actually, it does look like it would be a perfect square. And now lastly, how about this one? Again, it's a prism and it's named after the polygon at the base. 9, so it's a nonagonal prism. And here I get a rectangle as a cross section if I cut it just right with a vertical plane. Here you can see again, the cross section is actually a rectangle. Here's an interesting shape. What is it? You count the corners, it's a 7-sided shape or polygon, so then it is a heptagon. Alright, I hope this gives you an idea of how this thing works, cutting a solid with a plane and looking at the cross sections. And I hope you have opportunity to experiment yourself with some web-based program like what I'm using, or some others. GeoGebra has also some, so I will put the link in the description below the video. This is all. I hope this was helpful.